Hello, everybody. A warm welcome from Berlin. Today is another episode of AIOps Explained. Today we're talking about applying AI to predict and prevent outages using the latest release of the IBM Cloud Pak for Watson AIOps. And to detail this topic, I do have today as guest Jim Conallen with me. Jim, do you like to introduce yourself?
Thank you very much. Hi, I'm Jim Conallen. I'm an executive architect at IBM's Center of Competency, where we manage a number of AIOps environments, including some other things. That's it.
Nice. And I think you own now the official IBM demo systems within the IBM Cloud Pak for Watson AIOps.
Yeah, it looks like people are increasingly using ours, which is good. I think it's good because we started as a grassroots effort.
What I really like on this demo environment, it's not just the product itself, it's also several products themselves plus scenarios. And we do also have troublemakers, scripted troublemakers, which we can activate, as well as that they are used to demonstrate really specific use cases and intentions. And I guess you're going to use that during your demo, aren't you?
Absolutely. So we have an application set up called Quote of the Day. It's a simple microservices application, but what we've done is we've created it so that we can manually or arbitrarily induce specific anomalies. And those specific anomalies will, of course, travel through the system, and we can see how they affect the overall product, how they show up as alerts and stories and other things.
Wow, great. Today we are going to talk about Cloud Pak for Watson AIOps 3.4, of course, and we are going through a few, no, it's not slides. You are having a light board, isn't it?
Yep. Well,
cool.
Kind of draw with my mouse, but it looks like a blackboard.
Nice. And then we're going through two different use cases. The first use case is describing how to predict potential outages if there is a possibility to predict something is going to happen and impact a service in the near future, and how the Cloud Pak is going to detect this and what you can do with the Cloud Pak. As well as the second scenario addresses more or less the same thing, but we're not in a preventative mode anymore. We are in reactive mode. So still the Cloud Pak provides huge benefit in pinpointing what is the problem and what to do about a specific problem. And with that, I think I have said enough, and I'll hand over to you to kick off the whole thing. Thanks. Over to you, Jim.
Thank you very much.
Hi, for this AIOps 3.3 demo, we're going to begin with a little blackboarding session here, in which case I'm going to outline what our demonstration environment looks like. And we're going to start with the demo application over here. So this is just some kind of application or applications. In this case, it's a little microservice application that has multiple services, including a database. And this application is going to be monitored by AIOps and other tools. Now, when we're monitoring an application, one of the primary things that we look at is metrics. Metrics are the bread and butter of application performance monitoring. Metrics are structured information. All metrics reduce to some kind of a number, and because it's a number, we can kind of do math things on it and eventually produce alerts. So things like if the CPU exceeds 80% for a minute period of time, generate alert. And that's something that we're going to be interested in. Another thing that comes out of this that we want to look at is tracing information. Tracing information is all about following a user thread of activity into the system. So a user might hit this service might call another service, which calls the database, and then we're back to the original service and calls something else before returning the response to the user. Now, because the tracing is able to follow through all of this activity, now we can get dependency information, dynamic dependency information on all the services and databases. And that's really important when you're trying to monitor the application. Now, metrics and tracing information is structured information. It is unambiguous. It's either numerical values or identifiers, and their semantic meaning is fixed, and we know that. Now, lately, there's another kind of source of information that we can collect, and that is log information. Log information, on the other hand, is unstructured information. It's basically English phrases written out to a file by one of these components. So the component is going to write human readable lines to a file that indicate activity of that particular service. Now, because this is human readable natural language stuff, we just can't use math equations to find alerts and analyze the information. We need something much more powerful. And until recently, we didn't have the statistical or the AI methods necessary to process this information and actually make it usable. But now we do. We can process this information, we can look for patterns, and then identify when those patterns are broken or anomalies are detected. In our demo environment, the metric and tracing information is going to be collected by Instana. Instana is a tool that collects metrics, collects tracing information, and it will produce alerts, as well as metric information and the tracing information that we'll use later. The log information is going to be collected in our environment in an ELK stack, Elasticsearch. Any log aggregator will work, LogDNA, Splunk, Humio, whatever. And this log information is going to be presented to AIOps. So AIOps is here. And AIOps collects all of this information and assembles it all together and figures out which things are really important and which things are not. So log information is going to come in, and it's going to be analyzed to see if there's any anomalies. The tracing information is going to come in here, and it's going to be used to produce a topology that mirrors the actual topology, and by which log anomalies can pin themselves to a particular resource, or alerts can pin themselves to a particular resource. So this is how we collect everything and organize everything together, and advanced statistical and AI methods are going to identify anomalies, alerts, and if they are statistically significant enough, a story will get created. And a story is going to combine a number of alerts and anomalies together that are all related for one reason or another. And a story will be published with Slack or MS Teams. In our environment here, it's going to be Slack. Now, when an alert or event is made part of a story, there's something else that is associated with that is potentially is a runbook. A runbook is a series of instructions or automations that have been known to be effective against the particular alert or an anomaly in an application. So if this alert or anomaly matches certain conditions, and those certain conditions match an existing runbook, then the SRE can go to that runbook, follow the instructions, whether they're automated or not, and that runbook will go out and, if it's automated, actually do something to the service to fix it, or provide manual instructions by which the SRE can follow to correct the problem. And it's this demo environment here that we're going to demonstrate one particular use case where anomalies, log anomalies, precede an eventual failure in the system. So sometimes, and I'm not saying it happens in every case, but sometimes log anomalies will appear long before the actual service fails. If we pay attention to those log anomalies, we can prevent system failures in the future. So let's take a look and see how that is going to happen. In our sample environment here, we have a little anomaly generator, which I'm going to trigger right now, and it's going to initiate that first phase where the log anomalies are introduced into the environment, but the performance of the application doesn't change. There are no alerts. There's no CPU failures. There's no service failures. The application just performs as normal, even though the developer was writing the code indicates in the logs that maybe something is going to happen, or there's some change in the pattern of the logs. Off here on the right, I have Slack, so I'm going to just put a little marker in here that says the demo is starting. So all the stuff up above is from previous usage of the system. So we'll look for something to pop down here. While we're waiting for the first log anomaly to show up, let's take a look at the application real quick. It's a very, very simple small microservices application that if you navigate to the home page, you will be delivered with a quote of the day from a famous or semi-famous person. You can click on a button to display a random quote. You can click on the link of the author to see a short little biography and an image of the author or some picture for the author. There's also a rating system, and if you want to, you can invoke another system, order an engraving to have sent home, and if you really want to, display a PDF and save it for later. So it's a very simple application, and right now it's behaving perfectly normal. But I don't know if you've been noticing, but over here in the Slack channel, we got our first warning that maybe something is amiss. There's a log anomaly was detected in the image component. So that's the component that dishes up the images in the author bio. So let's take a look at that, some of the details there. It's associated with this particular application, our quote of the day application. It's assigned a story ID. The title is grabbed from the very first alert that appears. And in this case, it's just a single log anomaly. It's a major alert. So let's take a look at the details of that particular log anomaly. It says that abnormal behavior was found in the logs. Let's expand this. Some information on when it's happening, and what we see here is that it's an unknown pattern. So this is a log message that was never seen or never part of the training process by which AIOps understood is normal operation. So with this brand new pattern, something's wrong, and we should probably take a look at it. We can look at the logs of this particular pattern, and we see the log say a certificate's going to expire in less than 24 hours. The application is working fine, and I can verify that by going to Instana. And if we look at Instana, all of the graphs and the metrics look okay. As a matter of fact, in the past 10 minutes, there hasn't been a single erroneous call. The latency looks normal, the CPU's pretty flat, and we're not getting any significant errors, just the normal 200 and 300 response codes. So the application is running fine, but we get a log anomaly. So what do? Let's follow this. Well, the first thing I should do is say I'm going to start working on it by doing a self-assign. And then let's navigate to the application in AI Manager. AI Manager is calling up the application, and this is the topology. Remember we were talking about the tracing information that coming from Instana? It and other instrumentation has produced a large graph of components that make up our microservice. And the log anomaly that we're seeing in here, when I expose the story here, is happening on this particular resource. So this particular resource is experiencing the log anomaly. And I can go and look at the list of alerts for this story. That's just the one. Let's take a look at an overview. Here's the service. It's connected to some endpoints. But what's really interesting here is there are a number of runbooks that have been associated with the type of alert that's popping up here. And one of those runbooks says, update image service certificates. So that looks like it's probably going to do the job. So I can go here, I can run this particular runbook, Fortunately, it's fully automated, so I don't have to do any manual steps. I'm going to run the runbook. So the first step is to update the internal certificates. It'll run, give me some feedback. Then I move on to the next step. The next step is to reset the service. So I'm going to reset the service, and as soon as it's completed, it'll tell me everything's okay. I can complete the runbook, and I will verify that my anomaly has stopped. If I take a look at Instana, nothing has really changed here because it was never experiencing any stress to begin with. So I'm going to mark this as completed. And I can go back to Slack and say marked as resolved, but normally I would mark that as resolved. But what happens if I don't react to this early and I don't recognize the logs warning? What's going to happen is, 24 hours later, if I don't do anything, all heck's going to break loose. So I'm going to demonstrate that with a different invocation of our anomaly. And we're going to see what happens if we ignore those cert warnings, how the application would behave, and how AIOps would still give us an opportunity to fix it. It's just that at this point, some of the users might be disappointed of a service failure for a period of time. Now, let's take a look at the application itself. Now that we've initiated the failures, 24 hours later, we ignored the warnings. We still can do random quotes. We still get ratings and stuff. But when we go to look at the author biography, the images have stopped working. So none of the images for any of the authors seem to be working. So this indicates a system failure. While we're waiting for the other alerts to come in, I just wanted to point out that in addition to the alerts associated with the story that we have, there are other alerts, other log anomalies that have been detected that just have not been statistically significant enough to be brought to our attention. For example, these two log anomalies right here, they've been identified, but they're not associated with the story because they have a minor rating as compared to the other one that we had, which was a major significant rating. These other alerts don't generate a story, and that's based on policies. So this is something new with 3.3. We have policies that are associated with a lot of actions that happen. So we can control when things bubble up to stories, when things are activated, when runbooks are invoked. And in this particular case, let's filter just the stories. The policy that I have set up by default here is that story creation happens for high severity alerts. Those are majors and criticals. That's enabled. That's when I want to see a story. But I don't want to create a story for every single alert. That's just too much noise. It's not worth it. But the alerts are still shown. If I go down to here, even though I'm not creating a story to be sent to Slack, the log anomalies are still shown up there. And so I recognize that they're there, but we're not seeing a story for it. I'm going to jump to Instana right now, and we're going to see that the activity that we initiated because we ignored the certificate is happening. We're seeing now a lot of erroneous calls. If I zoom in on the author service, and in particular the one endpoint images that's being called, I can see that we now have a pretty much 100% 500 error rate because we can't get to the service because the certificate's invalid. It also introduced a significant latency in the service, and there's a lot of CPU time spinning its wheels trying to correct the problem. These alerts are getting generated, and if we go over to Slack, we can see that our story now has been updated with excessive CPU usage, memory usage, and as we look deep in here, we can see that there are alerts for erroneous calls and an additional log entry. So let's take a look at the details of our story that has had these things been added to it. Sudden increase in the number of erroneous calls, because we can't get to the image service the way we used to. And what's interesting here is we still have our unknown pattern for the logs. But what I'm going to do, we have a new log error here. And if we show the details on that one, it too is an unknown pattern. We can preview the logs. And we see that, well, now the author service is saying the certificate is expired. Sorry, can't do anything about it. The system has started failing. And so we need to fix it. So again, we go from Slack, we go to AI Manager. We take a look at all of the errors now. And now we can see that the errors are happening, here and here and here and all over the place because we just let it get out of hand. We ignored the log anomaly early on. So if we view all the alerts, we can see there's a whole bunch of alerts. We go back to the overview again and let's pick something. We can see a number of runbooks that are being suggested. So these are just the top 3 alerts. I can see that our runbook for updating the certificates is in here, and we can run it again. Take care of this runbook. It's going to create new certificates. Go to the next step, reset the service. And we can complete it. And I'm just going to put in runbook worked fine, even though we didn't verify it, but we'll verify it in a second. So just corrected that particular issue. If we go to Instana and we look at the live, we'll see, and it's hard to see right here, but we started to get some 200 status codes coming back, and we should see the latency drop off and the CPU time drop off at some point soon. And we can go and this time mark the story as resolved. And problem solved. Now we can go back to the quote of the day service, take a look at our images for the authors, and basically kill a little time looking at reading quotes. So the big takeaway here, there's a couple of takeaways. First, sometimes anomalous logs can warn us in advance of failures, even catastrophic failures. And by paying attention to them, we can avoid a lot of hurt later on. The other takeaway is logs are unstructured information. They're difficult to process. If we go and take a look at all of the logs, let me get rid of this, and try and just filter this ourselves, studying these logs and looking for minor changes in patterns and anomalous behavior is just really difficult. It's not something a human being is going to be able to do. And because it's not straight numeric data, our simple mathematical equations and simple algorithms don't apply. We need AI, we need advanced statistical methods in order to identify anomalous log behavior. And the third takeaway is I just want to say that AIOps 3.3 is the first release, in my opinion, that brings together all under the same UI, not disconnected separate ones, but the same UI, all of the information necessary for an SRE to be able to monitor metric anomalies, which we didn't show in this demo, but which are part of 3.3. Event information with log anomalies connected with runbooks, all in the same UI. And it's shaping up to be a pretty good release.
Wow, that was really a great demo, Jim. Thank you for that. And with that, we're going over to the documentation. Of course, we do have lots and lots of documentation. Here's a link into the most recent documentation. We just released the first fix pack for Cloud Pak for Watson AIOps version 3.4, which makes it together to IBM Cloud Pak for Watson AIOps version 3.4.1, to be most precise. And in here, you find all the bits and pieces about administering, installing, and requirements and all these kind of things. It's all there. And with that, we say thank you to your time, your appreciated audience. And we like to see you in another video of AIOps Explained, where we're going to talk about the IBM Cloud Pak for Watson AIOps and what you can do with it. Thank you and see you soon. Bye.